Hello, my name is Ngziwei, third year student from software major, and this will be my presentation for my final PBL report. For my report, I would like to focus more on the 6 components that we are expected to know for this course, and I will begin with the presentation. So these are some of the things that I've learned from the course, and let's move to the first one, SVD. Okay, so for SVD, it is basically a factorization of a matrix into many component matrices. And this allows us to discover some kinds of information such as the eigen decomposition. And this SVD method is normally used in least square linear regression, image compression, and denoising data. So in Sage, there is this function called SVD function which can decompose a matrix into U, S, and V. And in order to get back the original matrix, you just use U multiplied by S and V transpose. And as you can see from the results, when you do the multiplication, you will get back the original matrix. These two, M1 and SVD of M1. Moving to the next one, which is GDM, gradient descent method. It is basically an optimization method to find the local minimum of a function. And its goal is to minimize the given function, for example, the cost function. And in order to do that, first is to compute the gradient, which is the first order derivative. And after that is to make a step in a direction opposite to the gradient. And increase from the current point by learning rate times. What is learning rate? Learning rate is a tuning parameter in the optimization process, and it decides the length of the steps. So this is a simple algorithm with steps tracking. And basically it's to choose a starting point, calculate the gradient, make the step in opposite direction, and to continue this step of calculating the gradient and making the steps unless the max iteration is reached or when the step size is smaller than the tolerance. For data and covariance matrix, it is basically how much two random variables gets changed and computing the covariance in between every column of data matrix. And it's a useful tool to separate structure relations in a matrix of random variables. This can be used to decorrelate variables or apply as a transform to other variables. And this is a key element used in PCA. So this is a general overview of how a variance-covariance matrix will look like. Next, PCA. PCA is a technique to reduce the dimensional of datasets and increase interpretability as well as to minimize data loss, and is to create new correlationship between originally unrelated variables. So I got an example from online. As you can see, if there is too many cells, it's impossible to create many dimensional data because it's impossible to read. So what PCA does is it clusters the cells which have common features, such as in this case the genes. So it will increase its readability, interpretation of this dataset, and it's also to minimize information loss because everything is clustered nicely. Yeah. And for rank reduction is a dimensional reduction which is used to reduce datasets matrix into parts, such as SVD. And these parts are ranked, and these parts are selected to best capture the structure of the matrix and can be used to represent datasets. And this technique is mostly used in PCA. And last but not least is backpropagation. It is an algorithm used to train neural networks using a chain rule method. And after each pass, the backpropagation algorithm will do a backtrack which adjusts the model's parameters, such as in this case the weight and the bias. Why is backpropagation important is because it's important to adjust the parameter because we want our model to have the best predictability, to predict the best to have the best prediction whenever we have any input. Thus, it's important to adjust the parameters to achieve that. So this is how backpropagation is used. Yeah, so this is my participation. I have a total of 23 participation, and I've attended all the online lectures and all the 3 WebEx sections. So I think for this class, I think the best is good because it's using the Q&A, which we can learn to discuss all the questions and learn from others to see how people approach the questions. And this is my self-evaluation. Yeah, so the way I studied was by the lecture videos, the Q&A board, and online resources through just Google search research to improve my understanding. Yes, and I practice the codes through the SAGE program given. And these are the 2 students I would like to give credit to for helping me the most throughout these 15 days. And so, as I mentioned, I have a total of 23 entries in my Q&A. And for the project proposal, it is to create a neural networks with backpropagation. The method is basically to create a neural networks with the use of backpropagation, and it's in Swift. Yeah, so basically I just want to try to create a simple neural networks that can do backpropagation for my term project. Yes, and lastly, yes, as I mentioned, I learned a lot during these 15 days through the videos, lecture notes, and Q&A board. And I believe after this course, I'm able to talk about these 6 areas at least a bit to my friends or to anybody that is interested in it. With this, I end my presentation. Thank you.